Hello student, let's do this wonderful question which I have taken from magnetic effect of current. Okay, here in this question given the two long parallel wires carrying current of 2.5 ampere and I ampere in same direction. They are directed into the plane of paper, are held at point P and Q, here P and Q respectively, such that they are perpendicular to the plane of paper. The points P and Q are located at a distance. The distance of P point from this R point is 5 meter and the distance of Q from this R is given 2 meter respectively. An electron moving with a velocity of 4 into 10 raised to power 5 meter per second along the positive x direction, means the electron is moving toward this direction, experiences a force of magnitude 3.2 into 10 raised to power minus 20 Newton at R. And we have to find the value of I. What is I? I is the current flowing through the wire at point Q. So this we have to find here. Now let's see the solution for this question. So I have written all given things. The PR, the distance of wire at P from the point R 5 meter, and the distance of wire Q from the R is equal to 2 meter. I have written here, and the current through the wire at P I1 is equal to 2.5 ampere. This is also given, and the current through the wire at Q, which is I2, is I ampere. This is also given, and this we have to find. We know that current carrying wire always produces magnetic field. So we can, let's take P1, magnetic field produced at R due to the wire at point this P, and B2, the magnetic field produced at R due to the wire at point Q. So therefore total magnetic field at point R is equal to B, which is equal to B1 plus B2. And we know that the magnetic field produced by a wire at a particular point is equal to B, which is equal to E is equal to mu 0 4 pi 2 I upon R. So we can write here the values of B1. B1 is equal to mu 0 upon 4 pi 2 times I, the current flowing through the wire at point P, which is I1 we have taken, and divided by R, the distance of P from R, which is equal to 5, plus mu 0 upon 4 pi B2. So 2 times the current flowing through the wire at point Q divided by R is equal to 2. So we have to solve this. We'll get from here, this is common, so mu 0 upon 4 pi and 2 also we can take out. Inside we will be left with I1 divided by 5 plus I divided by 2. So we'll get here mu 0 upon 4 pi into 2 divided by I1 is given 2.5 divided by 5 plus I divided by 2. So we'll solve this. We'll get mu 0 4 pi multiply by 2. This is equal to 0.5 plus I divided by 2. Mu 0 upon, as it is we'll write. So this is 5 divided by 10 plus I divided by 2. So this is equal to mu 0 upon 4 pi 2 times is 1 by 2 plus I divided by 2. So this is equal to, this we know, this value we can put here, 10 raised to power minus 7 times 2 divided by, this is equal to 1 plus I divided by 2. So this 2 will get cancelled with this. So here the magnetic field B is equal to 10 raised to power minus 7 1 plus I. So here we have to see the direction of the magnetic fields also. So for that, as the wire at point P is like this, is going inside the paper, and the current is like this, and if we apply the right hand thumb rule here, we'll find that the direction of the magnetic field produced by the wire at point P on point R will be towards Y prime. And similarly, the direction of the magnetic field produced by the wire at Q at point R will be towards y prime, means negative y axis. So it means we can write this in vector form also. So this P prime is equal to 10 raised to power negative 7 1 plus I, and it will be towards negative y axis, minus j is equal to negative 10 raised to power 7 1 plus I j. Here we have to find the value of I. So next they have given that the electron is moving with a particular velocity, and the velocity of electron they have given v prime is equal to 4 into 10 raised to power 5 meter per second, as it is moving toward the x-axis. So I'll put here I vector. Value of the force on this electron, which is equal to 3.2 into 10 raised to power minus 20 Newton. And we know the value of the charge on the electron is equal to negative 1.6 into 10 raised to power minus 19 coulomb. And we know this formula, F is equal to Q times V cross the value of magnetic field. So here Q is equal to negative 1.6 into 10 raised to power minus 19. So V is equal to 4 into 10 raised to power 5 I unit vector multiplied cross product of B. B is equal to negative 10 raised to power 7 1 plus I j unit vector. Here we have negative sign and here also we have, so it will become positive. So we'll get force is equal to 1.6 into 10 raised to power minus, sorry, here it is 19 multiplied with 4 into 10 raised to power 5, this multiplied with 10 raised to power minus 7, and I cross j unit vector, and we know that I cross j unit vector is equal to k vector. So the force F is equal to, so here it will come 1 plus I also. If we solve all these things, we will get the force is equal to 6.4 into 10 raised to power minus 21 I plus 1 plus I k. This k is showing the direction of the force on electron. It will be towards the z axis. So if we take the magnitude of this force, this is equal to 6.4 into 10 raised to power minus 21 I 1 plus I, and we know that the force they have given F is equal to 3.2 into 10 raised to power minus 20. So this implies that these two values are equal. So this means the 6.4 into 10 raised to power minus 21 1 plus I is equal to 3.2 into 10 raised to power minus 20. Now we have to solve this and we have to find the value of this I. So this will become 1 plus I is equal to 3.2 into 10 raised to power minus 20 divided by 6.4 into 10 raised to power minus 21. So we have to solve. So if we solve this, we'll get this as equal to 5. So from here we'll get I is equal to 5 minus 1. So I is equal to 4. Is the current flowing through the wire at point Q. So this I is equal to 4 ampere. So this is what we have to find in this problem.